Hello students, this is Dilip Udhani and today I will teach you first order differential equations. First of all, we will understand what is order and degree. The order of a differential equation is the highest derivative present in the equation. And the degree of a differential equation is the power of the highest order derivative after clearing the radical sign and fraction. Radical sign means the sign like square root and fraction. The given differential equation should be a polynomial equation in derivatives. Okay. So we have examples. We have to find out the order and degree of a given differential equation. So problem number 1 is square root of x square d square y by dx square plus 2y, that is equals to d cube y by dx cube. So first of all, squaring both sides. So in the left hand side we have x square d square y by dx square plus 2y, that is equals to d cube y by dx cube. Here the maximum derivative is 3, that is d cube y by dx cube. So the order of this differential equation is 3 and the power of maximum derivative is 2, so the degree is 2, right? Now problem number 2, dy by dx plus y the whole raised to 1 by 2 equals to sin x. So first of all, squaring both sides, so the result is dy by dx plus y equals to sin square x. Here the maximum derivative is 1, so the order is 1 and its power is 1, so the degree is also 1. Now problem number 3, fourth order derivative d raised to 4y by dx raised to 4 plus sin y double dash equals to 0. Here the highest order derivative present in the differential equation is d raised to 4 by dx raised to 4. So its order is 4. The given differential equation is not a polynomial equation in derivative. You can see this is not a polynomial equation in derivative, as this term, that is sin y triple dash, this is a trigonometric function of derivative y triple dash, right? Therefore the degree is not defined. Hence the order for this differential equation is 4 and degree is not defined. For degree, the given differential equation should be a polynomial equation in derivative. Then and then only it will be defined, otherwise not, right? Okay. Now problem number 4, d square y by dx square the whole raised to 2 plus cosine of dy by dx is 0. Here the maximum derivative is 2, so the order is 2 and this is the t function of derivative, right? So the given equation is not a polynomial equation in derivative, so the degree is not defined. Now problem number 5, d square y by dx square equals to cosine of 3x plus sine of 3x, right? Here the maximum derivative is 2, so the order is 2 and its power is 1, so the degree is 1. Now moving on to problem number 6, that is y triple dash the whole square, then after plus y double dash the whole raised to 3 plus y dash the whole raised to 4 plus y raised to 5 equals to 0. Here the maximum derivative is y triple dash, so the order is 3 and its power is 2, so the degree is 2. Now in this example number 7, y double dash plus 2y dash plus sin y equals to 0. Here the maximum derivative is 2 y double dash, so the order is 2 and its power is 1, so the degree is 1, right? Now we have to find out the solution of first order differential equation, and the name of the method is variable separable form. So first one is 2x square dx plus x square dy equals to 0, right? So the problem statement is 2x square dx plus x square dy equals to 0. Taking x square dy towards right hand side, so we have 2x square dx equals to minus x square dy, right? Now you have to write down 2x dx as it is and divide this function by the x square which is in the right hand side and equals to, you have to divide dy by y which is in the left hand side. So this is called variable separable form. With dx you have to write down the function of x only, and with dy you have to write down the function of y only. So this is called variable separable form. Now 2x by x square, the result is 2 by x dx and equals to minus 1 by dy. Then after you have to integrate this result. Now integrating the above result, so 2 as it is, integration of 1 upon x, answer is log x, and integration of 1 upon y, answer is log y, minus sign as it is, and the constant value is plus log c. Now 2 log x, it will become log x square as per the properties of the logarithm, and log x, it will become log x raised to n, and minus equals to minus log y plus c. Now you have to keep this term of negative log y towards left hand side, so it will become plus log y, and that is equals to log c. Now as per the property of logarithm, that is log x plus log y, the result is log xy, so this will become logarithm of x square y equals to log c. Now cancelling the logarithm function both side, or you can say that log is a one-to-one function, so it will become x square y equals to c. So this is the required solution. Now moving on to second example, xy dy by dx equals to 1 plus x plus y plus xy. So the left hand side, that is xy dy by dx, and the right hand side is 1 plus x plus y plus xy. Taking 1 common from 1 plus x, in bracket we will be having 1 plus x, and taking y common from these two terms, we will be having 1 plus x in bracket. Now taking 1 plus x common from these two terms, so 1 plus x will be in one bracket, and in second bracket we will be having 1 plus y. Now separating the terms of x and y. So x as it is, 1 plus x as it is, and divide 1 plus x by x, and move this dx towards right hand side, and this one y as it is, and then after divide this y by 1 plus y and dy as it is. So this is nothing but a variable separable form. You have to write down the function of y with dy and function of x with dx. Okay, now we have to integrate this function. So what we have done, we have added 1 and subtracted 1 in the numerator. So it will become 1 plus y minus 1 over 1 plus y dy, and dividing 1 plus x by x, so it will become 1 by x plus 1. Now dividing 1 plus y by 1 plus y, result is 1, minus 1 over 1 plus y as it is dy, and this is equals to 1 by x plus 1 dx. Now integration of 1 with respect to y, answer is y, and integration of 1 over 1 plus y, the answer is logarithm of 1 plus y, and that is equals to integration of 1 upon x, answer is log x, integration of 1 with respect to x, answer is x, and plus c. So this is the required solution. Okay, now problem number 3, xy dash equals to y square plus y. X as it is, y dash is dy by dx, and taking y common from these two terms, so in bracket we have y plus 1. Now what you have to do, you have to separate the function of x and function of y. So you have to apply the concept of cross multiplication. So it will become dx over x and dy over y into bracket y plus 1. Over here we will be having dy, right? Now writing 1 as y plus 1 minus y, and divide by y into bracket y plus 1, and this is dx by x. Now dividing y plus 1 by y plus 1, so y plus 1 will cancel out, so we have 1 over y, minus dividing y by y plus 1, so y will cancel out, we have 1 over y plus 1, and this is equal to dx by x. Now integrating both sides, integration of 1 upon y, answer is log y, integration of 1 over y plus 1, answer is logarithm of y plus 1, and integration of 1 upon x, answer is log x, and plus log c is a constant value. Now applying the concept of logarithm or properties of logarithm, logarithm of y minus logarithm of y plus 1, it will become logarithm of y over y plus 1, and log x plus log c, it will become log xc. So overall the solution is y over y plus 1 equals to xc, right? Now problem number 4, 1 plus x square dy equals to xy dx. So apply the concept of cross multiplication. With dy, write down the function of y, and with dx, write down the function of x. So this x dx is as it is, and divide this term by 1 plus x square, and this dy will be as it is and divide it by y. Now dy by y, that is equals to multiplying this function by 2 and dividing by 2. Now integrating both sides, integration of 1 upon y, answer is log y, and 1 by 2 as it is. Now 1 plus x square is a function, and in the numerator we have its derivative, so the integration of this function will become logarithm of 1 plus x square plus log c. Now half logarithm of 1 plus x square, it will become logarithm of 1 plus x square the whole raised to 1 by 2 plus log c. Now this one will become logarithm of 1 plus x square the whole raised to 1 by 2 into c. So log y is logarithm of 1 plus x square the whole raised to 1 by 2 into c. So the required solution is y equals to 1 plus x square the whole raised to 1 by 2 into c. Done. Now moving on to example number 5. E raised to x tan y dx plus 1 plus e raised to x square y dy equals to 0. So taking this term towards right hand side and writing the function of x with dx and function of y with dy. So with dx we have e raised to x over 1 plus e raised to x, and with dy we have sec square y over tan y, and this minus sign as it is. Now integrating both sides, 1 plus e raised to x is a function and its derivative is e raised to x. So the integration of this function will become logarithm of 1 plus e raised to x. Then after this minus sign as it is, tan y is a function and derivative of tan y is the sec square y, so it will become minus logarithm of tan y. So this is logarithm of tan y is integration of sec square y by tan y plus log c. Now taking this term towards left hand side, so it will become logarithm of 1 plus e raised to x plus logarithm of tan y equals to log c. Now applying the concept of log x plus log y equals to log xy, so it will become logarithm of 1 plus e raised to x into tan y equals to log c. So log will cancel out, so the result is 1 plus e raised to x into tan y equals to c. This is the required solution. Now moving on to example number 6. Here cosine of dy by dx is a, where a is any real number and the initial condition y of 0 equals to 1 is given to us. Cosine of dy by dx equals to a. So dy by dx, that will become cos inverse of a. So now applying the concept of variable separable form, so dy equals to cos inverse a into dx. Now integrating both sides, integration of 1 with respect to y, the result is y, and integration of 1 with respect to x, the result is x, and the cos inverse a is a constant value plus c. Now the initial condition y of 0 equals to 1 is given to us, so based on this condition we have to find out the value of constant term c. Now what is the meaning of y of 0 equals to 1? It means the value of y is 1 when x is 0. So put down the value of x equals to 0 and y equals to 1 in this general solution. So y is 1, cos inverse a as it is, and x is 0 plus c. Cos inverse a into 0, the result is 0, so the value of c is 1. Now again put the value of c equals to 1 over here. So the required particular solution is y equals to cos inverse a into x plus 1. Okay. Then after further simplifying this one, y minus 1 equals to cos inverse a into x. So y minus 1 upon x equals to cos inverse a. So cosine of y minus 1 over x, that is equals to a. This is the required solution. Now problem number 7, cosine of x plus y dy equals to dx. Now we cannot convert this differential equation into variable separable form directly. So what we have to do, we have to suppose this function, let x plus y equals to t. Now differentiate this function with respect to x. Derivative of x is 1, derivative of y is dy by dx, and derivative of t is dt by dx. So from here we have dy by dx equals to dt by dx minus 1. So replacing dy by dx by dt by dx in this equation and x plus y by 1. First of all, write the equation in this form, that is dy by dx equals to 1 upon cosine of x plus y. Now replace dy by dx by dt by dx minus 1 and 1 over cosine of x plus y by t. So dt by dx equals to taking minus 1 towards right hand side, so 1 over cos t plus 1. Now taking cos t LCM, so we have 1 plus cos t over cos t. Now applying the concept of variable separable form, with dt we have to write down the function of t, and with dx we have to write down the function of x. So it will become cosine of t over 1 plus cos t dt equals to dx. Now adding 1 and subtracting 1 in the numerator, we have 1 plus cos t minus 1 over 1 plus cos t equals to dx. Now dividing 1 plus cos t by 1 plus cos t, result is 1, and 1 by 1 plus cos t dt equals to dx. Now 1 as it is, 1 as it is, and 1 plus cos t. We have one formula for 1 plus cos t. The result is 2 cos square t by 2 dt, that is equals to dx. And 1 over cos square t by 2, the result is sec square t by 2, and 1 by 2 as it is, 1 as it is, dx as it is. Now integrating this result, right, integration of 1 with respect to t, the result is t half as it is, and integration of sec square t by 2, result is 10 t by 2, and the coefficient of t is half, so divide it by half, and integration of 1 with respect to x, answer is x and plus c. Okay, now replace t by x plus y, and this half will cancel out, 10 of replace t by x plus y by 2 and equals to x plus c. You can see that this x and x, this one x and this one x will cancel out, so we have y minus 10 of x plus y by 2 equals to c. So this is the required solution. Okay. Okay, now moving on to second topic, that is homogeneous differential equation. If the degree of each coefficient of dx and dy is same, then it is homogeneous differential equation, right? Over here you can see that the degree of x square, that is 2, the degree of y square, that is 2. So these are coefficient of dx, and over here the degree of x square is 2. This is coefficient of dy. The degree of xy is 2. This is coefficient of dy. So what is that written over here? If the degree of each coefficient of dx and dy is same, then it is called homogeneous differential equation, right? To solve this type of differential equation, what we have to do, we have to take y by x equals to v in a given equation, or x by equals to v if dx by dy is given. If dy by dx is given, take y by x equals to v. If dx by dy is given, take x by y equals to v. Now we have to solve this differential equation. You can see that this is a homogeneous differential equation because the degree of each and every term is 2. The degree of x square is 2, xy is 2, x square is 2, y square is 2. So this is a homogeneous differential equation. Writing this in this form, dy by dx, that is equals to x square plus y square over x square plus xy. Now y by x equals to v, so we have y equals to vx. So replacing y by vx, so it will become v square x square plus x square as it is, plus x square as it is, plus x as it is, and y by vx. So dy by dx equals to taking x square common, so into bracket we have 1 plus v square. So taking x square common, so into bracket we have 1 plus v. And as y equals to vx, so dy by dx, that will be v as it is, derivative of x is 1, plus x as it is, and derivative of v is dv by dx. So replacing dy by dx by v plus x dv by dx, and x square will cancel out, 1 plus v square over 1 plus v. Now we have to apply the concept of variable separable form. So x dv by dx, that is equals to 1 plus v square over 1 plus v, taking v right hand side, so it will become negative v. Now taking LCM 1 plus v, so it will become 1 plus v square, minus 1 into v minus v, plus minus minus v into v square, and divide by 1 plus v. So v square will cancel out, so in the numerator we have 1 minus v, and in the denominator we have 1 plus v. Now apply the concept of variable separable. With dv we will write down the function of v, and with dx we will write down the function of x. So apply the concept of cross multiply. So 1 plus v over 1 minus v dv equals to dx by x. Now integrating both sides. So integration of 1 plus v over 1 minus v dv equals to integration of 1 over x dx. Okay. Now this 1 plus v, you can see 1 plus v as it is, and we have added 1 and subtracted 1, right? So 1 plus 1 is 2. Now taking minus sign common, so into bracket we have 1 minus v. You can see that this result and this both are same. 2 minus 1 is 1 and minus minus plus v, right? And divide by 1 minus v. And that is equals to 1 by x dx. Now dividing 2 by 1 minus v and 1 minus v by 1 minus v, the result is 1. And integration of 1 upon x is log x plus c. Now 2 as it is, and integration of 1 over 1 minus v, answer is logarithm of 1 minus v, and multiplier of v is minus 1, so divided by minus 1. And integration of 1 with respect to v, answer is v. Now replacing v by y by x, this will become minus 2, logarithm of 1 minus v is y by x minus v is y by x equals to log x plus c. Then after multiplying the whole equation by minus sign, so this is 2 logarithm of 1 minus y by x plus y by x equals to minus log x minus c. So now applying the concept of logarithm, property of logarithm, so it will become logarithm of x minus y over x the whole square plus log x, and that is equals to this minus c as it is, and taking plus y by x towards right hand side, it will become minus y by x, and we have taken minus log x towards left hand side. Now applying again the concept of logarithm or the property of logarithm, that is log x plus log y equals to log xy. So it will become logarithm of x minus y by x the whole square into x equals to minus y by x minus c. Right? Now writing this in exponential form. So this one term will be as it is, and considering base as e, so x minus y by x the whole square into x, that will become e raised to this term, that is minus y by x minus c. So one time x will cancel out. So in the denominator we will be having x one time only. So now taking this x towards right hand side, applying the concept of cross multiplication. So we have x minus y the whole square equals to c into x into e raised to minus y by x, where this capital C is e raised to minus c, right? So this is the required solution. Now problem number 2. Now we have to solve this differential equation. So first of all, divide this differential equation by x. So it will become dy by dx minus y by x. X will cancel out, sine of y by x, that is equals to 0. Now you can see that this is a function of y by x. Everywhere you will find out y by x, right? So what you have to do, you have to take y by x equals to b. So first of all, write down dy by dx equals to y by x minus sine y by x, and put y equals to vx, and dy by dx equals to v plus x dv by dx. So dy by dx equals to v plus x dv by dx, y by x is v, minus sine y by x is v, so minus sine v. So v will cancel out, we have x dv by dx equals to minus sine v. Now with dv write down the function of v, and with dx write down the function of x. It means applying the concept of variable separable form. So dv by sine v equals to minus dx by x. Now 1 over sine v, that is cosec v. So cosec v dv equals to minus 1 by x dx. Now integrating both sides. So integration of cosec v is logarithm of mod of cosec v minus cot v equals to minus integration of 1 upon x is log mod x plus log mod c. So left hand side is as it is. Now log mod c minus log x. So applying the property of logarithm, that is log x minus log y, that is log x by y, so it will become log c by x. So the overall result is cosec v minus cot v equals to c by x. Now replacing v by y by x, so it will become cosec y by x minus cot y by x equals to c by x. So this is the required solution. Thank you for watching this video.